Shyam, when we say that the jet streams, they don't allow for the mixing of the air. For example, in any region, if there is a jet stream, it doesn't allow the mixing of the air underneath. So if you talk about the frontal formation happens underneath them itself. It is basically, if let's suppose in certain areas, the warm air tends to push into certain regions. So the jet streams also vary accordingly. Okay. So, but in general, what is the condition is that many of the times, even that frontal formation that you observe on the ground surface, that is also very much dependent upon where the jet stream is in existence. Generally, in the region where the jet stream is in existence, it is in that region where you have the temperature difference on the lower surface, also in the upper surface, also. So that is why you don't need the air to simply cross underneath it and then form a front somewhere. Okay. I hope that is understood. So, Lakshana, just ensure that you revise it. Whatever you have studied, revision is paramount. Otherwise, whatever you are reading, just simply going through, it is not never going to give you confidence, and you have to solve questions. In winters, isotherm bend towards equator or depends upon oceans and continents. Rohit, it depends upon the oceans and continents. Ziba, that is correct. Okay. So, good morning to all of you, and welcome to Baiju's Exam Prep IAS. Welcome to another session of geography, where today we shall be moving ahead with the properties of the oceans and also the details about the physical properties and the movements that we observe in case of the oceanic surfaces. Now, in the previous session, we had initiated the discussion about the global distribution of climatic conditions. What are the various climatic conditions that you experience in different parts of the globe? And then, along with that, we had also initiated the discussion to understand the oceans, where we had started the discussion about the bottom relief of the oceans, where we discussed that when we talk about the bottom relief, now they are either, in a way, they can be considered to be volcanic in terms of their origin, they can be considered to be tectonic in terms of their origin, or they can be a product of erosion or deposition as they get created. So that is basically the case of the oceanic temperature. Now, now we will initiate the discussion about oceanic temperature. So when we talk about ocean temperature, we have to understand that in the terms of the oceanic water, temperature tends to vary from one region to another due to certain number of factors. And temperature also varies as you start going into the depths. Okay. Even as you start going to the depths, the temperature tends to vary. And even as you move from one region to another, the temperature tends to vary. Now, what is the prime source of heating when it comes to the oceans across the world? So, here, when we talk about any kind of an ocean, any kind of an oceanic surface, let's suppose, in that case, the prime source of heating is always considered to be the solar insolation. Solar insolation provides the heat to the oceanic waters. That is the main source of heat. So that means the amount of heat which will be garnered, which will be accumulated on the surface, will be maximum, and the amount of heat which is experienced at the lower regions will end up decreasing. This is why, in general, you will observe a kind of a scenario where the temperature of oceanic water tends to start decreasing as we move into the depths. So that is why here, in terms of the oceanic water, temperature tends to decrease with an increase in depth. in the depth of water. But you have to understand that when you have to study and when you have to analyze the oceanic temperature, you have to analyze the variation in oceanic temperature both based upon different latitudes, right? That is the horizontal variation of temperature, horizontal variation of temperature, and also we have to study the vertical variation of temperature. So, first of all, we shall be taking a look and try to understand the horizontal variation of temperature, and then we shall be focusing upon how is it that the temperature ends up increasing or decreasing when we talk about the depth of it. So starting first of all with the temperature and its horizontal variation. So the prime source of heating is the solar energy. And we have also seen that the process of heating and cooling of the oceanic water is slower as compared to the land. So, what that means is, I will summarize this, even though we have talked about it multiple times. But basically, what it means is that oceanic water is cooler than land in summer, and also oceanic water is warmer than land during winter. During winters. So basically, it ends up signifying that the temperature in the ocean, it tends to basically show a kind of a slightly delayed behavior where it will take a lot of time for the oceanic water to gain temperature. But as soon as it warms up, it will continue to maintain that heat. So that is why during the winter season, while the land will cool down quite sufficiently, the land will lose heat quite significantly. Oceanic water tends to lose heat slightly in a slower proportion. Now, here also you will observe, in terms of the thermal map here, the thermal imaging and the thermal mapping of the oceans, you will observe that different areas indicate different range of temperatures from the region of equator right to the region of the poles. You will observe a significant amount of variation. Just like how we studied the case of the isotherms, the variation in temperature in the northern hemisphere, it is much more haphazard, much more staggered. Whereas when we talk about the variation of temperature in the southern hemisphere, it is much more uniform. So that is why in the southern hemisphere, you will observe that the variation in temperature is almost parallel to the latitudes. But in the northern hemisphere, it is dependent upon where you have the distribution of land and water and the other factors such as ocean currents, the when we consider the latitudinal extent, all of them, they come into proportion. Now here, when we take a look at the various different factors which affect the temperature distribution, the first important factor is that of latitude, latitudinal position of the oceanic water. Now, when we talk about the oceanic waters, and or in any case, when we talk about the variation in insolation, we do know that the amount of solar insolation is going to be highest in the lower latitudes, and the amount of solar insolation keeps on reducing as we move towards the higher latitudes. So that means as we move towards the higher latitudes, there is a kind of a cooler condition which is prevalent, and that is also reflective in the temperature indicated by the oceans. So surface water temperature decreases from equator polewards because of insolation. We do know that insolation is maximum near lower latitudes. Insolation is maximum near the lower latitudes. Then after that, you have unequal amount of distribution of land and water, right? So, for example, oceans in northern hemisphere, they have a greater amount of contact with the landmass as compared to the oceans of the southern hemisphere. That is why the oceans in the southern hemisphere, they will have lesser impact of heating of land mass thereby, whereas in the northern hemisphere, as the land will get heated up, because it is in contact with the water body and you have increased proportion of the land masses, that is why in the northern hemisphere, the impact of the temperature of the land masses will be much more prominently felt over. So that is why more heat is received in the northern hemisphere when it comes to the oceans, not the overall northern hemisphere. Only in terms of the oceans, you will have the fact that more heat is received. Why? Because oceans in the northern hemisphere has more contact with the land. As a consequence of it, when the land gets heated up, that heat is also translated into the water body. So there we do know that as the land areas get heated up, the heat is translated into the heating of water. By virtue of being in contact due to the process of conduction. We have also seen in the case of Indian Ocean dipole, haven't we? That when we talk about a greater amount of heating of the Horn of Africa region or the eastern portion of Africa, whenever the eastern portion of Africa and the Arabian Peninsula, they get extraordinarily heated up, the portion of the Indian Ocean adjoining it or right next to it will also get substantially heated up. So there you understand that the warming of the land will have an influence over the nearby water body as well. Then the existing winds in any area or the prevailing winds in any area, they also influence the oceanic temperature of that region. How? So when you have winds blowing over a region, so generally, especially across the coastal regions, you will find that either the wind action is trying to carry away the surface water. As a result of that, there is upwelling of the subsurface water. Sometimes you will find that basically the wind is carrying more water and dumping into a region, accumulating into a region, so there will be downwelling of the water, right? So we do know that whenever you have onshore offshore winds, that does have the potential to impact the oceanic temperature. For example, if you consider two ends of the ocean, two ends of the ocean, let's suppose. Now, if the wind is blowing in this direction, let's suppose this is the consistent movement of the wind. As the wind is moving in this direction, it will carry some amount of surface water along with that. Now, as the surface water is carried along by the wind, the lower subsurface water, they rise up to replace the depleted surface portion. The subsurface water, they rise up to remove or basically fill up the depletion on the surface which is created. So this is the process of upwelling. Okay. And in the case of upwelling, we have seen earlier when we were studying upwelling at the time of Walker circulation, there itself we have studied that when we talk about upwelling, what happens to the oceanic temperature in that area? That leads to a significant and a substantial reduction of oceanic temperature, isn't it? So here in this region, upwelling leads to or causes a reduction in ocean temperature. Okay, it causes a reduction in terms of ocean temperature. Now then, in certain areas, as for example here you see onshore winds. Now onshore winds means all the surface water is being carried along, and that surface water ends up accumulating here in the coastal areas, and there is a kind of a downwelling, right? So the surface water is pushed in the lower portion, so you have conditions of downwelling. Questions have been asked previously in the prelims based on the principle of downwelling and upwelling. We'll discuss that in due course of time. But you do have questions associated with that, whether the water in the eastern margin of the ocean or the western margin of the ocean, whether that will be warmer or that will be cooler. So these sort of questions have been already asked. Now, downwelling basically means it will increase the surface temperature. So, in any particular area, in the region of any particular ocean, depending upon what is the direction of the wind movement, whether the winds are onshore or offshore, depending upon that, you have the variation in terms of temperature. But nonetheless, just remember, upwelling means subsurface water is coming up, right? Water from the lower regions is coming to the surface, and we do know that water in the lower regions is cooler as compared to the surface. Why? Because the source of heat is the solar insolation. So that solar heat will be impacting the surface most of all. And as you go into the lower regions, you will find colder water. So that is why when the subsurface water rises to the surface, that means you have sea surface temperature which immediately plummets. Whereas if warm surface water is being accumulated in an area and then being forced down due to downwelling, that means you will observe a kind of an increase in sea surface temperature. Then you also have the existence of the ocean currents, and the properties of the ocean currents also impact the temperature. Now, ocean currents, again, let me reiterate, we will be studying very shortly. Today itself, we will be studying the details of the ocean current, the different types of ocean currents which are in existence. But in general, when we talk about ocean currents, what we are referring to is the movement of, like, a stream of water in a certain set direction, in a particular area, in a particular motion. So where you have a regular movement of oceanic water from one region to another. So the oceanic water, let's suppose it is getting moved from the lower latitude to higher latitude. It will bring warm ocean currents, right? It will bring basically warm water. Let's suppose in Atlantic Ocean, due to these oceanic currents, there is movement of water from lower latitudes to higher latitudes. Means it will bring warm water to higher latitudes, isn't it? If I can depict it on the map here, or a simple schematic here, let's suppose if we consider this the region of equator. Now, if you have an ocean current like this, okay, now this ocean current is bringing warmer waters or water from the lower latitude to the higher latitude. Now, we do know that water at lower latitude is of higher temperature always, isn't it? So here, this means water or ocean currents from lower to higher latitude, bring warmer waters to the higher latitudes, increasing the temperature in higher latitudes. And vice versa is also true. If you have an ocean current which is moving, let's suppose, from the region of higher latitude to lower latitude, it means it is bringing water from here into the lower latitudes. And bringing water, basically, when we talk about they bring water from the higher to the lower latitude, means they are bringing colder water into the lower latitudes, right? So this ends up varying, or this ends up determining the variation in ocean temperature across various different areas. For example, if I can take you back to the thermal image, here you will observe that in this region, suppose in this area, observe how the warm water has got a kind of a streak like this. Now, this is because here you have in existence an ocean current which actually carries warmer water right up till this, right? So that is why here you will have higher oceanic temperature in general. Here you will find that in comparison, you have a colder water in this region. In comparison, here you will find colder water, here warmer water. That is because an ocean current from this region brings colder water in lower latitude. This is the reason why when we talk about the regions of North Sea, when we talk about the regions, for example, the area around Scandinavian region, when we observe the area around, for example, we talk about, let's suppose, the Kola Peninsula area. Now, that is where we have noticed, that is where we have observed that many of the port cities in the northern part of the Eurasian subcontinent, they tend to remain ice-free through the year, just because the prevalence of these warm ocean currents. You have warm ocean currents moving towards that in the form of North Atlantic drift. That brings warmer waters into the northern portion of Atlantic, and that keeps the water in many of the regions ice free, and that keeps the ports still functional through most of the year. Otherwise, in these higher latitudes, you'll find that the port region generally freezes up, and that means no business can be carried out thereafter, no ship movement can be carried out thereafter, right? So here, example, when we talk about example, so presence of warm North Atlantic drift keeps much of northern Atlantic ice free through the year. Example, port of Murmansk. Locate this Murmansk with the help of Google. Okay, later on, after the session, locate this port of Murmansk, where this is situated around the region of the Kola Peninsula. Do locate that. And then overall, you will understand that how it is basically in these higher latitudes, it is only because of the presence of the warm ocean currents that the region tends to remain ice-free for the most of the year. Okay. Now, when we talk about the variation in temperature, you have to understand that variation is dependent upon the fact that whether that sea or the ocean is considered to be enclosed from all sides, or whether it is open from all sides. When we say the ocean being open from all sides or open seas, we are talking about examples such as the Atlantic, the Pacific, the Indian Ocean. Now they are larger areas which are open rather, and they are interconnected with the various other oceans also. But when we talk about, let's suppose, the Black Sea, the Mediterranean Sea, then, for example, North Sea, the Baltic Sea, Now, these end up being enclosed, and thereby the property of the land, heating and cooling of the land, will impact the temperature in the enclosed seas quite significantly. Okay, so when we talk about enclosed seas, means surrounded by land almost on all sides or in very close vicinity. So enclosed seas here refers to large water bodies surrounded by land in close proximity. Now, thereby, when we talk about the open ocean, such as the Atlantic or such as the Pacific, or even, for example, the Indian Ocean, if we consider, the variation in temperature experienced from one area to another, that variation in temperature is very gradual. Okay, that variation in temperature, let's suppose to the lower latitudes to the higher latitudes, you will observe a gradual cooling, for example, right? Now, but when we talk about enclosed seas, there the impact of the temperature of the land will play an important role. Okay, so in this case, whenever we talk about enclosed seas, so the impact or the temperature experienced has got a heavy influence of the heating and cooling of the landmass. So in this, temperature variation is influenced by heating and cooling of landmass. Okay, the variation in temperature from one region to another is influenced by heating and cooling of the landmass. So that means when we talk about the lower latitudes, closer to the equator, landmass will be much hotter. In comparison, landmass will be much hotter there. So that is why enclosed seas in these regions will also be warmer in comparison. So Mediterranean in comparison to the same latitude, at the same latitude, Atlantic will have a slightly cooler temperature as compared to Mediterranean. Why? Because Mediterranean is being surrounded by landmass. So as the heating of the landmass will happen, that will heat up the Mediterranean Sea also. Whereas Atlantic does not experience any of those particular predicaments. So that is why at low latitudes, enclosed seas have higher temperature due to greater heating of the landmass. Due to greater heating of land. Whereas, if we talk about, let's suppose the Baltic Sea here, let's suppose the Baltic Sea, and compare it to the temperature in the Atlantic at the same latitude. Let's suppose you are comparing it to the temperature in the Atlantic at the same latitude. Now here, the land around Baltic Sea will become very, very cold because land loses heat very quickly. So the land loses the heat very quickly here. So as a result of that, the water body will also start becoming cooler, right? So in comparison to the Atlantic, Baltic Sea will be much more colder, right? So here at high latitudes, open seas have higher temperature, enclosed seas are colder. Enclosed seas are colder. Example, you have Baltic Sea. And why is it that the enclosed seas are colder? Due to colder landmass in higher latitudes. Okay. due to the presence of colder landmass when we talk about the higher latitude. That is why you will find that the open seas, they are generally warmer in the higher latitude, and it is the enclosed seas which are colder in the higher latitude. Now, these are your various different factors which end up influencing the oceanic temperature in different areas. Where in the lower latitudes, we do know that the oceans experience a higher temperature, and in the higher latitudes, the oceans are colder. So, observe this thermal image. This tells you that this, first of all, tells you multiple things. One of the things that it tells you is that how in the southern hemisphere, in the region of the southern hemisphere, basically you will observe that in the case of the southern hemisphere there is a variation in temperature which is almost parallel to the latitudes, which tells you that there is a kind of a uniform distribution or a uniform variation in temperature which is experienced. Why? Because of predominance of the water bodies. Now in the northern hemisphere you will experience the variation depending upon the predominance of the land masses, where the land masses are present in what condition. For example, observe the Atlantic. If you observe the region of the Atlantic, you will observe that in general, there is a kind of a variation at these latitudes. For example, if you consider the 20-30 degree latitude, Atlantic will have slightly cooler waters because the water has started cooling down as you are moving across the latitudes. But observe the region of Arabian Sea and Bay of Bengal. They are very, very warm in comparison. Why is that the case? Because first of all, Bay of Bengal is a very small water body surrounded by land in significant vicinity, in proximity. So the land in this area, when that gets heated up, the region of Bay of Bengal also will get heated up, and there is not much of a circulation of water happening here. So the water tends to get heated up for a prolonged duration, right? So you have factors such as ocean current influencing the temperature. Then you have the influence of temperature in terms of whether it is enclosed sea or open sea. So enclosed sea and open sea, the fundamental is very simple. What do we mean by enclosed sea? Enclosed, it is not a specific location somewhere, that enclosed sea is situated in the Pacific 200 kilometers to the east. No. Enclosed means surrounded by land from all sides. That is the meaning of enclosed. Open means which is open from all directions. So when we talk about the variation in temperature in the case of the enclosed seas, we do know that in the lower latitudes, you will have the land which is significantly more heated up. So at the same latitude of the Atlantic Ocean, you will observe that water is cooler in the region of Atlantic as compared to the Mediterranean. Why? Because the Mediterranean is surrounded by land masses. Mediterranean will get heated up, and that is where you will observe Mediterranean indicating a higher temperature as compared to Atlantic. Observe here the Red Sea. In this region also, the heating of the Arabian Peninsula and the heating of the region of Africa, that will heat up the Red Sea also quite substantially. Now, when we talk about the higher latitudes, in the higher latitudes, the land will be much more colder. So, as the land is much more colder, the enclosed sea will also become colder. But in the case of the open ocean, you don't have any such factor of cooling of the vicinity, which will lead to lower temperature. So here also temperature lowers, but not at the same rate as you observe in the case of the enclosed seas. Okay. I hope, Purva, now it is understood. Now, after this, we come to the portion of horizontal, or rather vertical distribution of temperature. How is it that the temperature tends to vary as you start moving into the depths of water? So there also we are aware that as we start moving into the depth, as we start going deeper and deeper into the water regions and into the water bodies, the temperature tends to decrease. And the reason for that is very simple, because the prime source of heat is the solar insolation. The prime source of heat is basically the solar insolation. Now, the sunlight won't be able to penetrate till the bottom of the ocean. Sunlight will be able to penetrate only up to a certain depth. Isn't it? Beyond that depth, sunlight won't be able to penetrate. So let's suppose we talk about the ocean, and this is your, let's assume, the ocean floor, which can have a depth of 4 to 6 kilometers from the sea surface on an average. Now, here if you consider the sun, now the solar rays, they will fall upon this region. Now, the solar rays won't be able to penetrate to the lowest of the areas. Let's suppose the solar rays, they are able to reach only up till a depth of 1000 meters or 1 kilometer from the surface is where the solar rays are able to penetrate. Generally, it is around 400, 500 meters, in rare cases around 1000 meters from the sea surface. That is the level where the solar rays reach. Now, the region where you have the penetration of the solar rays, that is known as the photic zone of the oceanic water. So, wherever you have the availability of the solar rays, that is what is referred to as photic zone. Availability of solar rays. And then for a larger proportion, you have no solar rays which are available to a greater depth. So lack of availability of solar rays. Okay. So at the bottom of the ocean, when you consider the bottom of the ocean has not received sunlight like forever, unless and until there is a kind of a plate tectonic movement, that region gets uplifted closer to the surface. Bottom of the ocean is not exposed to solar rays. That is why when we talk about the marine life in the bottom of the ocean, that is the benthic zone, or the what species we specially refer to as the benthos. Now benthos have been used to throughout their life cycles and throughout the life cycles of their ancestor, and in the process of evolution also, the benthos, they have never been exposed to solar rays, so they are very well adapted to live in permanent and perpetual darkness with no availability of solar rays. Now in this case, when we talk about the variation in temperature, so the temperature will be highest at the surface, isn't it? The temperature will be highest at the surface, and then as we start going down, the temperature starts to decrease. Let's assume I draw a graph. This is the temperature graph, and this is the graph of depth. Let's suppose this is the level of the sea surface. This is your sea surface level. Now, at the surface of the sea, temperature generally in the tropics is around 24, 25 degrees Celsius. Let's assume 24 degrees Celsius. So at the surface, the temperature will be 24 degrees Celsius. As you start going lower, the temperature tends to reduce. Eventually, at this particular depth, at these depths, if you consider these areas, the depth of these regions, if you consider, where the solar rays eventually will disappear after a particular point of time. So in this depth, the temperature will start to reduce almost drastically, isn't it? Because suddenly the solar rays are disappearing in that area. So suddenly you are entering into a region which has never been exposed to solar rays. So that is why the temperature starts to dip, the temperature starts to decrease quite substantially. And then eventually, as you reach the lower portion, you reach a region of consistency where there has never been any sunlight. So there you will observe that you have a consistency of temperature, right? So this is how in a vertical region or in a vertical dimension from the surface to the bottom, how is it that we experience a variation in temperature? So that is what is referred to as the vertical distribution of temperature. So this is the reason why you will observe in this zone where the solar rays, they start reducing in intensity and suddenly disappear. In this particular zone, you will find a significant and a sudden drop in temperature which is experienced. So this is a zone of transition. Zone of transition, where the temperature reduces quite drastically and quite suddenly. That is the zone of transition. And that is what we refer to as thermocline. Okay. So where cline means a kind of it, a variation, right? And thermo dealing with temperature. So because here you have a sudden decrease in temperature, sudden variation in temperature, this zone of transition of temperature is what is also referred to as thermocline. Okay, so that is how you will observe that the temperature tends to reduce from the surface lower on. So if you observe the thermocline, thermocline is the area where there is a rapid decline of temperature. It is a boundary region, can extend from 100 to 400 meters below the sea level. So observe again, at the surface, the temperature is around 24-25 degrees Celsius, right? Now, as you start moving into the depth, as you start moving into the depth, the impact of the solar rays start to reduce. Eventually, you will be able to reach that particular depth where the solar rays are not able to penetrate anymore. So suddenly, you will experience that water which has never been exposed to warm solar rays. So that water will be colder, isn't it? So that is why, as you move from the surface to the lower region, you come across that zone of transition where the temperature will tend to reduce quite substantially. And that is what we refer to as thermocline. So this is the zone which is known as where you experience a decrease in temperature, substantial decrease in temperature, as at these depths solar insolation becomes very less. Solar insolation tends to become very, very less here. Okay. And eventually leading to colder waters of aphotic zone. Aphotic zone. Okay. So when we talk about, for example, the photic and the aphotic zone. So generally thermocline is in that zone of transition between the photic and the aphotic zone. That is where you will have partially the photic zone where you will have a slightly higher temperature, and as you start moving into the region of the aphotic zone, it will be colder water. So that is why this variation in temperature. Hence, when we talk about the vertical distribution of temperature or the vertical variation of temperature into the oceanic depths, it is highest at the surface and observe at the lower regions in the aphotic zone. In the lower areas of the aphotic zone, it is almost consistent. Why is that the case? That is because here you will find that the conditions are uniform. This region has been aphotic zone, has never received sunlight. So it won't have much variation because of wind movement, etc. That impact will never reach downwards. So because you have uniform conditions at a depth, that is why at the depth you will have consistent temperature. And that temperature is maintained around 4 degrees Celsius. Roughly, even at the bottom, in majority of the oceans, the temperature is maintained around 4 degrees Celsius. And why is that the case? Why is it that the temperature is maintained around 4 degree? Why isn't the case that the temperature decreases? to 1 degree or 2 degrees Celsius because of the simple property of water. Water experiences significant amount of compression and pressure from above. The amount of pressure that is exerted from above is very, very high. And due to that pressure, there is compression. So obviously, the density will tend to increase in the lower portions. The density tends to increase. Now, density of water is highest when at 4 degrees Celsius. That is the property of water. Now, if you cool water below 4 degrees Celsius, if let's suppose you freeze it, it basically has a lower density because beyond that, beyond cooling, or if you cool water beyond 4 degrees Celsius, the molecules, they start forming crystalline structures. They start forming large crystals. And hence, they need a spacing between them. So that is why ice is lighter than water and ice tends to float on water. So this is the reason why the water cannot be compressed if the temperature is reducing beyond 4 degrees Celsius. Water cannot compress, it has to rather expand. Now, at these depths, when we are talking about the depth of 4 kilometer, 3 kilometer, pressure is so very high that the water cannot expand. Just to give you an idea about the pressure existent in that region, at these particular depth, the pressure is so high that think about it, that even a large submarine, if it reaches this particular depth, immediately it will be crushed like a soda can that you buy from the market after you drink the soda, then you crush it off, isn't it? So, almost similarly, if let's suppose you have a large submarine that you put at the ocean bottom, it has got the potential to get crushed. So, here, water has got the highest temperature, highest density, highest density of water is experienced at 4 degrees Celsius, means it cannot be compressed beyond that. Okay, so that is why at the lower region, where the density is the high, where the compression or the pressure is the highest, water tends to maintain that highest density. At the lowest region, pressure is the highest, and hence water maintains highest density at 4 degrees Celsius. Roughly around 4 degree. It is not exactly 4 degrees Celsius in itself. So roughly around 4 degree Celsius. Okay. So that is the case of the ocean temperature. Okay. And Atharv, sir, can we say that thermocline and photic zone is complementary to each other as temperature is influenced? Not exactly complementary. When we talk about thermocline, thermocline basically partially exists in the photic zone and partially it does exist in the aphotic zone. Okay. Why ocean will have higher pressure at the lower region? Why do you think? What is pressure? Weight exerted. So the pressure, the weight exerted at this portion will be higher, or the weight exerted at the bottom will be higher? Have you ever tried lifting one glass of water? If you keep one glass of water on your head, you will feel some pressure, but keep a bucket of water. Think about the pressure which is experienced. That will always be much higher. Aditya, what are the factors which affect the temperature distribution of ocean water? That is what we have answered, and that is what we have discussed till now, Aditya. In all the portions, when we have talked about the prevailing wind conditions, when we have talked about the proximity to the landmass, the solar insolation, whether it is an enclosed sea or an open sea, all those basically are the reasons why the temperature varies in ocean from one area to another. Then how people reach the ocean bottom if there is a lot of pressure? Do you think people reach the ocean bottom by free diving? That is simply start diving into the ocean water and they reach the depth of the ocean? No. If you have to reach these depths, right, you need a special uh, vehicle for that. You need a special vessel for that. That is where you had the Titan submersible, which would go to the ocean floor in the region of the Atlantic in order to witness the shipwreck of the Titanic. And that is where the Titan submersible, because there was some issue, that immediately it crumbled, right? It crumbled and then imploded, and you did not even find larger remains of it. When we talk about exploring the Indian Ocean bottom, why is it that India has launched a separate mission for it, Samudrayan mission, which it has been working for close to around a decade now, and where you have the Matsya 6000, a special vessel which has been designed. Look at the vessel; it is almost rounded like a capsule, so that it can be able to tolerate the pressure. And Sakshi, how at high latitude open seas have higher temperature? At higher latitudes, look at it in other way. At higher latitudes, enclosed seas have lower temperature. Means open oceans are bit warmer in comparison. Always understand it is in comparison. It is not the case that at higher latitude the water will be warmer than what is there at the lower latitude. No, at higher latitude, in comparison to the water at the same latitude, at higher regions, you will find that in enclosed seas it is colder, open ocean is a bit warmer. At lower latitude, if I encapsulate it, let's suppose if I were to encapsulate it at this particular latitude, if the temperature here is, let's suppose, 23 degrees Celsius, here it will be 25 degrees Celsius because it is surrounded by landmass. At higher latitudes, if the temperature here, let's suppose, is 12 degrees Celsius, here it might be around 8 degrees Celsius, right? So that is where the temperature is reducing with higher latitude, with the change in latitude. But in the case of the enclosed seas, there's a different dynamics. If it is surrounded by landmass in the higher latitude, means the water will be much colder. If it is surrounded by landmass in the lower latitude, water will be warmer. I hope that is understood now. Sakshi. All areas of aphotic zone has a temperature. Please stop writing. Please tell after this. After the questions, all the areas of aphotic zone has 4-degree temperature. Not all the areas will have the same degree of 4 degrees Celsius. It will be around 4 degrees Celsius, 4.1, 4.2, 3.8, somewhere around that region, you will have the temperature. Okay. Does any human being reach up till the... So you have controlled missions which have been carried to the bottom of the ocean. You have various missions which have also started exploring the Mariana Trench. Okay. And are there liquid water of 4 degrees under the Arctic also? Yes. Even in the case of the Arctic, at a substantial amount of depth, you do have liquid water which is available. Okay. Right. I hope we have solved the questions. Yasmin, I'm understanding everything which you are teaching, but at the same time, I'm feeling I'm not understanding. I cannot do much with that kind of a feeling, can I? So in that case, Yasmin, just ensure at the end of the classes, you end up revising everything or try to write it down in your own words. Is warm water around the equatorial region? Yes, Anjali, that is correct. Okay. And okay, I think that answers all. Now, after that, we come to the portion of oceanic salinity. Now, we do know that when you compare a river water to a sea water or an ocean water, there's a difference. For example, and I'm sure you would have had a dip in the river sometimes, a dip in the ocean water sometimes. Ocean water turns out to be very salty and slight amount of common salt that taste comes into your mouth. So that is your salinity. So generally, when we talk about salinity of any particular solution, we are talking about the total amount of salt content. Okay. So oceanic salinity refers to the total amount of salt content which is present in any volume of ocean water. Generally, for reference, we consider 1 kg of ocean water. So the total amount of salt content in 1 kg of ocean water. Now, when we consider the oceanic water, let's suppose we consider the oceanic water here. Now, here you will have water molecules. Water molecules you will have to be present there. Now, along with the water molecules, you will also have various different compounds, for example, calcium sulfate, then magnesium chloride, sodium chloride, which is the most dominant of them all. So they will be present here. So the overall proportion of salt per kg of oceanic water reflects the oceanic salinity. Okay. So let's suppose in this 1 kg of oceanic water that we are considering, 1 kg of oceanic water that we are considering, let's suppose there is 30 grams of salt. So here, when you need to depict the oceanic salinity, how do you depict it? So oceanic salinity in this case will be 30 grams per kg, isn't it? 36 grams per kg. Now this is also in the units of gram. So 30 grams per 1000 grams. So we can say salt content is expressed in parts per thousand, amount of salt in 1000 grams of water. So this is representative of amount of salt, amount of salt per kg of water. So that is represented in parts per thousand. Per thousand. Now that parts per thousand, that is also referred to as PPT and is indicated by the symbol like this. So this is indicative of parts per thousand. So the oceanic region and the oceanic water consists of various different kinds of compounds and ions. For example, the river, when it comes into the ocean, it brings some amount of calcium sulfate. For example, the rocks which are present near the oceans, they will end up giving out some amount of sodium chloride, NaCl. For example, again, certain areas, you will have magnesium ions also, sulfate ions also, chloride ions also. So all of them, they interact with each other to form various different kinds of salts. NaCl is the most dominant salt, but there are other types of salt also. It is the NaCl which is present in predominance that lends that kind of a salty taste in the mouth after you have the oceanic water. If let's suppose you end up having oceanic water inside, it is very, very poison. It is not at all advisable because that much amount of salt intake will lead to various issues inside, but we are not going to go into that. But basically, that is why you feel that salty taste because sodium chloride is predominant. Now, here also in the case of oceanic salinity, just like the temperature, we have and we will study about the horizontal variation of salinity, horizontal variation of salinity, and also vertical variation of salinity. We'll study both of these, that whether there is a horizontal variation or a vertical variation. So, the total content of dissolved salt in seawater is called salinity. It is calculated as the amount of salt dissolved in seawater of 1000 grams and hence is expressed in ppt or the parts per thousand. Seawater is primarily made of many ions with chlorine, sodium, sulfate. These are the predominant ones. Hence, you find amongst the different types of salts, NaCl is also present, calcium sulfate is also present, magnesium chloride is also present, magnesium sulfate is also present, potassium sulfate is also present. So that is why in the presence of these different types of ions, you do have the predominance of various different types of salts. Now, where do these salts come from? Right? What are the sources of these salts coming from? So we'll take a look at that. But these are the overall salts that are present. And here you will observe that basically sodium chloride is the maximum. Okay, it has got the maximum proportion, that is of sodium chloride. Then comes magnesium chloride, magnesium sulfate, calcium sulfate, potassium sulfate, calcium carbonate, magnesium bromide. All these are the various different types of salts which are present. On an average, when we consider the oceans across the world, on an average, the salinity is around 35 parts per thousand. On an average oceanic salinity is around 35 parts per thousand. Okay, so that is the average salinity, means in 1 kg of water you will come across 35 grams of salt on an average. That is the average proportion of salts which are present. Now here, observe that out of the 35 grams of salt on an average, considered on an average, you will observe that 78% is almost sodium chloride, around 11% is magnesium chloride, around 4.7% is the magnesium sulfate, around 3.6% is the calcium sulfate. Ideally, these top four should be remembered for prelims. Now, let us take a look into the aspect that when we talk about the salts, what are the sources for the addition and the removal of salt in the ocean? So, when we talk about the addition of salts, so let's suppose you have an underwater volcanic eruption. Let's suppose now that will add calcium, potassium, even for example, some amount of chloride, some amount of sulfate, that will also be added, right? Because whenever you have volcanic eruption, sulfur dioxide is a gas which is released. So sulfate ions will be there. Then, for example, when you have the rivers coming over, they will bring some amount of carbonate, some amount of calcium, sodium, sulfate, that is brought by the rivers. From the sediments and the rocks getting dissolved, again sulfate, magnesium, they are dissolved. Sometimes even sodium is dissolved, right? So all these various different processes, they keep on adding salt to the oceanic water. Along with that, you have organic components also present underwater. Organic compounds will also add some or the other kind of nutrients or salts, maybe chloride, maybe sulfate, maybe potassium, maybe magnesium, maybe sodium. And these salts will start combining with each other to form calcium sulfate, potassium sulfate, magnesium sulfate, sodium chloride, calcium chloride, magnesium chloride, potassium chloride. So these salts will combine with each other. But here, if you think about it, when we consider these oceans, they keep on being added and getting added by various different salts. All these salts, they keep on getting added to the oceans, right? Now, if that is the case, and the oceans have been in existence for billions of years, why is it the case that still the salinity is maintained at 35 parts per thousand? Ideally, if the salts are getting on, keeping added on into the ocean, why is it that the salinity is maintained only at 35? Why hasn't it increased to 100 grams per parts per thousand on an average? That is because these salts, time and time again, they are removed and they basically get dissipated also. For example, if you consider calcium carbonate is to be found in the oceans. But that calcium carbonate is utilized by the species, such as when you consider the mollusks, right? Or the any kind of crustacean that you consider, crabs, lobster, etc. They use the calcium carbonate to build a kind of a hard shell around them. When you consider corals, the corals, they are able to build their exoskeleton by assimilating the calcium carbonate around them. So, like that, you have many of the species which end up using so organic processes and biological processes. They utilize up calcium, they use up calcium carbonate. Then, other than that, many of the times you will come across a scenario where many of these salts, they get together with each other, they form a large particle, and they start sinking to the ground. So many of these salts eventually will get deposited at the ocean bottom, and then they are no longer present to be in the part of the dissolved water anymore, isn't it? So you will have that kind of a larger accumulation of many particles forming a larger salt and then dropping them. Then, whenever you have a large wave coming over, the sea waves, you would have seen sea waves, isn't it? So whenever you have the sea waves here, let's suppose in any particular area, the sea wave is coming over. Now, generally, I don't know if you have observed it or not. Now, when these sea waves they come over, small amount of sprays, they are carried away by the wind. Or even if they will hit a rock, you will have a lot of spray of water. Now, if there is a strong wind motion, if this is what is by the way known as the sea spray. Now, if let's suppose you have a wind motion, wind movement, let's suppose. Now, this wind has got the potential to carry this sea spray away, isn't it? Now, this sea spray has got the amount of salts. Many of the times, these winds, they lift it upwards. And these are also very minute droplets of water containing salt particles, etc. They are also lifted easily by the wind. They are carried away for far distances. And that is when they reach a particular height, they can undergo condensation. And around that particle, around the sea salt which are present, condensation can happen. That is why sea spray also eventually as they rise up, because they consist of these salts, many of the times these sea spray, they also serve as the hygroscopic nuclei. Remember hygroscopic nuclei that we studied? What was hygroscopic nuclei? We observed that when you consider dust particles, some amount of these dust particles, they allow condensation to happen around them and lead to eventual cloud formation. They allow the water to stick to them. So those are hygroscopic nuclei, and that is why the presence of dust particles is very essential for the cloud formation, as we have seen here. This sea spray with the dissolved salt, when it is carried upwards, that also ends up serving as the source of cloud formation. So here, carried upwards by winds, the salt present in the droplets can serve as hygroscopic nuclei. They can literally serve as the hygroscopic nuclei. So that is the case of the salinity. Now that salinity, oceanic salinity, varies from one area to another depending upon a multitude of factors. Depending upon the fact that whether in a region you have evaporation, rainfall, greater amount of evaporation, less amount of rainfall, or if the rainfall is almost absent and only evaporation is happening. Then depending upon the fact that whether you have melting of ice happening in a region, or freezing of sea surface water is happening in a region, or when we talk about, let's suppose, the movement of wind also impacts the level of evaporation. So if in an area the wind movement is very strong, there will be greater evaporation also, isn't it? And this you would have observed from your day to day experiences. When you put out cloth, or a wet cloth, or after you have washed a cloth, when you put it out, you hang it out outside, you would have observed that when the conditions are windy, your cloth dries up fast. Why is it so? Because the cloth will lead to, the liquid water will get converted into water vapor, and if there is movement of wind, that vapor droplets will be carried away, more evaporation will happen. So wherever you have river water emptying itself into the sea, there also you have a variation. So there are multiple different variations of oceanic salinity. As you can observe here, that the surface water salinity depends on evaporation. In a region, if there is more evaporation, means more salinity, precipitation. If there is less rainfall, means more salinity, flow of river water, and freezing and thawing of glaciers. Now, how do you deduce that whether it will increase the salinity or decrease the salinity? So, in order to come to that understanding, we will adopt a simplified measure of understanding it at the level of the particles, whether you have a net addition of water molecules due to any event, or any event such as freezing, melting, evaporation, rainfall, whether it is leading to net addition or net removal of water molecules. So variation in surface salinity, variation in surface salinity by the aspect of due to addition or removal of water molecules. So let's suppose here we consider any particular column of water, let's suppose. Okay, let's suppose. Now, if we have the presence of water molecules in this, let's suppose we have the presence of water molecules in the spacing available between them, between the water molecules, is where the salt molecules will also be present. Calcium sulfate, sodium chloride, potassium chloride, they will be present in the spacing between them. Let's suppose these are where you have the presence of the salts. Now, when we talk about salinity, we basically are talking about the proportion of salt in the water, isn't it? We talk about the proportion of salt in a volume of water. That is what we represent in terms of salinity. Let's suppose here water tends to evaporate in a region. There is evaporation. Now, when evaporation will happen, will the salt molecule also rise up in the atmosphere, or will it be the case that only water will evaporate? What do you think? Water and salt combinedly they can evaporate, or whether only water can evaporate? What do you think in the case of evaporation? Okay. Okay. So all those of you who have said that combined or both of them will evaporate, do one thing: take a glass of water, put some salt in it, dissolve that, keep it out in the balcony. Ensure that the salt is adequately dissolved in that water. Keep it out in the balcony for today, right? And in the afternoon, in the evening, bring that glass back. You'll find that the water has disappeared, but all the salt which was dissolved in the water is now left behind in the glass. So salt molecules, how is it that they will evaporate? They will never evaporate. Evaporation happens only with that of water. The salt is actually left behind. That is how you basically make sea salt. Have you ever thought about it? You would have read about Dandi March, Gandhiji's Dandi March. Gandhiji went up till the region of Dandi and made salt. How did Gandhiji manufacture salt? All those who have said that both of them will evaporate, how is it that Gandhiji manufactured salt? Was it by some divine intervention that he held a stake and hit it on the ground and suddenly the seawater got converted into salt? Do you think that happened? Or do you think somebody provided him salt from the sides? How is it that Gandhiji manufactured salt? Basically by evaporating seawater. That is how you have salt which is left behind. So, whenever evaporation happens or whenever evaporation takes place, it is only the liquid water which is lost, and the solid salt particles, they will always be left behind. Okay? I hope that is understood. All those who had, I'm not going to take names, but all those who had said the combined water and salt, both of them will evaporate. I hope now it is understood. So, after evaporation, you will find that the water droplets have evaporated. Water droplets have evaporated, but the salt hasn't. The salt has actually remained behind. Now, as compared to the earlier scenario, as compared to the earlier case, what can I say about the proportion of salt with respect to water? Proportion of salt with respect to water is higher in case 1 or is it higher in case 2? What do you think? The amount of salt per unit water is higher in 2 or in 1? Obviously, in 2, you will have more salt per unit water in 2 because water has been lost here, right? So here we can see there is increase in proportion of salts as compared to water. Or we can say there is an increase in salinity. Okay. So whenever due to any condition there is removal, net removal, not overall, net removal of water, that means there will be an increase. Now you have more salt per unit water. So that is why that means there will be an increase in salinity. So whenever net addition or net rather removal of water happens, there is an increase in salinity. So why is it, or in which substances, or in which circumstances will we come across net removal of water molecules? We'll observe them to happen in cases when you have, let's suppose, evaporation and also freezing. Whenever there is any freezing action where the surface water, some part of it freezes, it is not that the entire surface of the seawater will be frozen into hard ice. That is never the case. But whenever you have the conditions of freezing for, suppose, very low temperature, so certain sections of the seawater, they will get converted into ice chunks. Now that freezing, when it happens, it can have some amount of salt molecules, but mostly ice will consist of water or salt. Mostly ice will consist of water, frozen water. So there is a removal of water from the seawater or from the ocean which was present. Some amount of water has been removed in the form of ice. So that is also going to lead to an increase in salinity. From where salt comes in seawater? Why do I get a feeling that few of you are putting that? Have we discussed this, or did you miss out this entire discussion, my dear friend? Where the salt comes from, where the salt is digested from. So you have various sources of salt: underwater volcanic eruption, river water discharge, then, for example, the sediments and the rocks getting dissolved, over land volcanic eruption leading to the kind of some amount of materials getting deposited. If, let's suppose, there is excess amount of rainfall, that also starts carrying over. So that is basically all of them will bring about salts. Okay, right? Now, that is basically the variation in surface salinity. Shyam, in geomorphology, you told that oceans are formed by raining for 7 years. 7 years? Did I say 7 years? No. Rainwater is not salty like ocean water, but oceans are formed due to the rain consist more salinity. There are multiple things in this question, which is absolutely out of the place, Shyam. But understand, first of all, the oceans, they got created after it continued to rain for more than 10,000 years. For more than 7,000 to 10,000 years, it continued to rain consistently. That started leading to the formation of oceans. Secondly, when you consider rainwater around 4 billion years back and you consider the rainwater today, do you have the feeling that both of them are same? If that is the feeling, it is absolutely incorrect, because when you talk about the proto atmosphere, the earliest of the atmosphere, it consists of various gases. Large amount of volcanic eruptions would happen on a day to day basis. Millions and trillions of volcanic eruptions would arise from the earth's surface. A lot of these particles, dust particles, would be carried by the rain. For a substantial duration of time in the Earth's history, you only had acidic rain, which continued to fall on the land, right? And you only have acidic rain, which continued to fill up the oceans. Then, for example, when we consider the rainwater, it is not as if only in the regions where you have the oceanic areas, only there it is raining. Land areas are dry. So even if you have rainfall on the land areas, that water will eventually be carried over to the low-lying regions, to the oceanic areas. So let's suppose you have normal rainfall over the land areas. It will carry the sediments, it will carry some amount of deposits from the land areas. For example, I hope you would have observed rainfall in your life. When you observe rainfall, let's suppose you accumulate water in certain area, in the drain nearby or in a pond nearby, you allow rainwater to accumulate. But the rainwater which is falling on you and the rainwater which is accumulating, can you go there where the rainwater is accumulating and straight away start drinking from there? That rainwater which has accumulated will be muddy, murky, will have many of the contaminants. Whereas the rainwater which is falling, it might still be cleaner. I hope we are able to understand the difference. Many of us, we are unable to understand why that salt is coming in the, okay. In the meanwhile, Anita, I have a second repeated question from you, where the salt comes in from seawater, in seawater. Okay. Is my voice reaching you, Anita? Am I audible to you? Or is it all happening in a parallel universe somewhere and you are till that point of time consistently typing questions? Is my voice reaching you, my dear friend? Yes? So just now I explained the answer to your question only, that why salt comes from sea, where salt comes in the seawater. Okay. Okay. How many of us still have the doubt in the fact that why seawater is salty? Water in my house is clean, then how come seawater is salty? How many of us have genuine doubt in the fact that when we talk about salt, what is the uh, source of salt? Okay. Try to understand this. All the keyboard warriors, please stop typing for a moment. Try to understand. When we talk about oceans, they have multiple different geomorphic processes. What do we mean by salts? When we talk about salts, do you think salt is only the common salt NaCl that you consume, or can salt consist of something different? It is a rhetorical question, don't reply. Basically, when you talk about salt, there is another misconception strangely in our minds, which tells us that the salt that we put in vegetables, in the food, that is the only salt which is present. Everything else is garbage. That is the salt. That is not the case. Salts, salt is the name given to compounds, chemical compounds, where you have anions, cations, they interact with each other, or when you have positive, negative, they interact with each other, they combine with each other. That is when they form a compound that is known as a salt, right? I'm sure, even though it appears to be very far-fetched, but I'm sure you would have read basic chemistry in your 6th, 7th, 8th standard. Not about 11th, 12th. I'm not even going there. 6th, 7th, 8th standard, you would have studied acid, base. Acid reacts with base to form a salt. I hope some of that is recallable. If that is the case, right, some of that, I hope. I seriously start doubting the kind of school information that we have nowadays. Okay. So many of us are not aware. Forget it. When we talk about salt, we are talking about compounds such as sodium chloride, magnesium sulfate, calcium sulfate, potassium sulfate, calcium carbonate, magnesium bromide, potassium bromide, and so on. So these are your salts. Now, how do they get created? So, in the ocean, in certain areas, let's suppose you have Na plus. In certain portions, you have chlorine minus. Na plus, which is present in water, will combine with chlorine minus, and that is where you will have NaCl. Ca2 plus, which is present in water, SO4 2 minus, which is present in water, will lead to formation of CaSO4. These are your salts. So where do you get this Na plus, Cl minus, Ca2 plus, SO4 2 minus? That is where you have this particular portion, this particular slide, which I'm sure was not paid attention to. So here you have, for example, underwater volcanic eruption. Whenever you have underwater volcanic eruption, you have sulfate, SO4 minus, you have Ca2 plus, you have Cl minus. All of them are provided underwater. These ions are present underwater. Let's suppose the river drains from the region of the Himalayas all the way till the region of Bay of Bengal. It will move across a large area of different types of rocks. Some rocks will have sodium, some rocks will have calcium, some rocks will have chloride. So as the river brings about the eroded material into the sea, it will bring calcium, chloride, sodium, potassium, magnesium into the sea. Now, these will combine with each other into the sea to form these salts. Then, when we talk about the sea interacting with the ocean, with the rocks nearby, the sea or the ocean, that will start dissolving the rocks. It will have some amount of materials which are dissolved by the rocks. So those materials of the rocks can have sodium, calcium, potassium, sulfate. I don't want to go through the entire list again. There also you have these ions which come in. There also you have combination of these and the formation of the salt. Is that understood now? If it is still not understood, then kindly take a look at the recordings thereby. Is that understood? No? Okay. Now, the variation in salinity. When we talk about the variation in salinity, so we have seen that whenever there is a net removal of water, either by evaporation or freezing, the amount of salinity tends to increase. So, for example, in areas in water bodies where the temperature is very high, temperature is very high means the rate of evaporation will be very high. The rate of evaporation is very high means there will be significant amount of the salinity will be increasing there, because evaporation means net removal of water is happening. Okay. Now let's suppose there is precipitation or rainfall. So basic sciences of class 6 to 8, many of us have not studied that. Isn't it that the case? When I find the issues with freezing, melting, the basic sciences are not. So I want to understand this, that I hope in your school days you had these science classes. No science. How many of us have had no science classes in our school days? studied. Okay. And I'm assuming that we would have had passed the examinations, right? Or how many of us have come across in a system where you never had to appear for the exam, the no detention policy, the golden dust of no detention policy, that no exam, you keep on moving from one grade to another. Okay. Mm, fair enough. So see, don't get disheartened by the fact that you are unable to understand the basics in any portion, in any area. If the basics are not understood, please don't get disheartened by the fact. Please start looking at the basic portions. Basic portion, for example, if you take a look at the recorded lectures, the pre-recorded lectures, before climatology, I have put a separate module of basics for those who are not comfortable with what is evaporation. Suddenly he is using the term condensation. Suddenly this guy is using the term latent heat. What do we understand by that? So go through that module of basics first, right? Those basics, please don't take it as an ego issue that now I am so well formed, I am so well developed, I can have social media argument with anyone, etc. How am I supposed? Throw all the ego on the side, straight away go to the basics. I have seen candidates, and this is a very real thing out there. Many of us, we have not, or many of the students, they don't pay attention in the school days, or as the many of them are a byproduct of the no detention policy, that they never had to appear for any of the exams. So obviously there is not many incentive to study. I have come across candidates who have picked up, in order to understand the basics, they have picked up the basic NCRT books of science of 6th, 7th, and 8th. Do that. It will come to your rescue, it will come to your help, because questions from the basic sciences are also asked. Don't wait for the science and tech faculty will come, then he will teach us what is the evaporation, condensation, saturation, unsaturation, what is reaction, catalyst. Don't wait for someone. Start studying those basic NCRTs on your own. And that should be the effort, that if I have to understand this thing and the base is not clear, let me build up the base. Let me not wait for someone to give me a structure and then I will understand that. So start working on this. Maybe you'll have to work harder than your competitors, but so be it. If you are determined enough to achieve the goal, you should have the incentive to do that also. So all those of you who have that weakness, who have that drawback, you will be your best judge. Standing here, I cannot tell you. So please go ahead and take a look at the basics. Okay. And now, coming to the increase in salinity. When we talk about the increase in salinity levels, here, let's suppose in a water, you have the presence of water molecules and the salt. Let's suppose there is rainfall. Now, whenever rainfall happens, some amount of dust particles will also be brought by them. Some amount of dust particles, some amount of solid particulate matters will also be brought by them. But then, mostly, rainfall will bring what? Water molecules. Mostly, rainfall will bring water molecules. There will be a net addition of water molecules. Right? Now, you will have salts which were present earlier. You will have salts. But in proportion to the earlier scenario, or in comparison to the earlier scenario, the proportion of salts has increased or decreased in this case. Obviously, in comparison to the earlier scenario, you will have more water now. Means salinity level has reduced. So that is where proportion of salt as compared to earlier will be reduced. So decrease. in proportion of salts as compared to water. And that means decrease in salinity. So in this case, whenever net addition of water happens, decrease in salinity. Now, under what circumstances will there be a net addition of water? So let's suppose precipitation or rainfall. Let's suppose melting of ice will add water. Then, for example, surface runoff and river runoff. Runoff and river water. Whenever river water goes into the sea, it will bring sediments also. It will bring sediments and deposits also. But in total, if you consider at any point of time, is the river carrying more sediment or more water? Always more water. So there will be net addition of water into the oceans. So here, surface water salinity overall, if you take a look at the horizontal variation, it depends upon evaporation. So any region, if there is more evaporation, means what? More evaporation means more salinity. If there is less rainfall or precipitation, more rainfall means less salinity. Less rainfall means more salinity. Okay? More rainfall means less salinity. Then, whenever you have fresh flow of river water emptying into the sea, thereby you will have addition of fresh water and hence more flow leads to less salinity. Freezing and thawing of glaciers. So, thawing means breaking and melting. So, when we talk about freezing, it is about removal of salt. And that means, or removal of water rather. That means increase in salinity. Thawing or melting of glacier means, thawing means melting. Here, melting or breaking is the actual meaning of thaw, but for this sake, it means addition of water. And that means decrease in salinity. Okay. So these are the various factors on which the surface level variation of salinity happens. So here, for example, if you observe the factors which can lead to increase in salinity or the increase in the salt content, freezing. So when you have some amount of water, surface water getting converted into ice caps, glaciers, etc., that means there's net removal of water from the system. Evaporation of seawater, then precipitation or rain or snow. For example, river runoff, melting of ice, groundwater supply, all of this leads to net addition of water and hence reduction in salinity. Okay. Okay. How many of us have the feeling that Dead Sea is the most saline water in the world? I'm taking a look at a few questions. How many of us have a feeling that Dead Sea is the most saline water in the world? Okay, so that is incorrect. So basically, we will study about why salinity increases in a certain area, which is the most saline portion of the world. It is not Caspian Sea either. We'll study about it after we come back from break. Yes, Rohit, that is correct. Rajneesh, correct. So here we take a break. We take a break of 10 minutes and then we'll be back. No, Great Salt Lake is also not most saline. It is Lake Van in Turkey, which is having the highest amount of salinity. A confirmation about the audio, please, guys. If the audio is clear and available, kindly confirm. Thank you. So now we move ahead with the aspect of understanding the variation in salinity in various parts of the planet based upon the very basic understanding of where how much amount of precipitation and evaporation happens. With this, we can formulate a kind of a trend about variation in salinity in different latitudes. Now, how? Let us try to understand that. So, here you see a graph. The red line indicates the precipitation experienced in a region. The dashed blue line indicates the level of evaporation. Let's start with equator. Now, in equator, at the region of equator, we experience everyday occurrence of rainfall. And please understand this concept here once and for all, and that will be done. So, at the region of equator, you receive the daily occurrence or you experience the daily occurrence of rainfall at equator, isn't it? Now, every day evaporation happens and there's formation of clouds. There is significant amount of large amount of precipitation happening in the region of equator owing to the maritime condition of the air masses. So here, observe at the region of equator, that is the doldrums as we refer to it, the precipitation is quite significantly higher. The amount of precipitation is quite significantly higher, right, as compared to evaporation. Precipitation or rainfall reduces salinity, evaporation increases the level of salinity. So here, because precipitation is higher, so salinity will be at the lower end slightly. Now, I'm not saying it is the lowest, but it is not very high. Let's come to the region of horse latitudes, that is the tropics. For example, in the region of subtropical high or in that area in the vicinity, because there are occurrences of high pressure conditions, you experience a kind of a complete lack of rainfall in that area. The subtropical high pressure regions are the deserts of the world that we have seen. So you experience a substantial lack of rainfall in that area, isn't it? But due to very hot condition and warm condition, evaporation will be very, very high. The rate of evaporation will be very, very high here. So observe how the evaporation is high and precipitation is almost minimum in the region of the tropics. Now, evaporation will increase the salinity, and there the rate of evaporation comparatively is very high. That is the reason why in the region of the tropics, because the rate of evaporation is very, very high, due to that, it is amongst the most saline areas of the world. So salinity in general, first of all, in general, salinity levels decrease from equator polewards. And secondly, evaporation or salinity is maximum at tropics due to high rate of evaporation. So all those saline areas of the world that you have heard about, for example, Dead Sea is something which fascinates everyone. because of the various numerous different kind of stories which revolve around them. Dead Sea, present in that tropical area. Lake Van, present in the region of subtropical high pressure. Great Salt Lake, present in the subtropical high pressure. So most of the highest saline water bodies that you will observe will be present in the region of the tropics. But will it be present in the northern hemisphere or southern hemisphere? In general, the salinity at the tropics in the northern hemisphere is higher in comparison to the southern hemisphere, because in northern hemisphere you have greater proportion of land. Greater proportion of land means greater amount of heating. Greater amount of heating means higher rate of evaporation, and a higher rate of evaporation means increase in salinity. I will repeat this again. In general, you will find that the tropics of the northern hemisphere have a higher salinity as compared to the tropics of southern hemisphere. And that is because in the northern hemisphere, you have a greater proportion of land masses. Greater proportion of land masses in the tropics means there is a greater heating, which is caused of the water body also. Greater heating of the water body means greater rate of evaporation, and a higher rate of evaporation means an increased salinity level. So that is why basically you will find that the salinity levels are quite significantly higher in the region of the tropics. So here, when we talk about the horizontal distribution of salinity, so overall salinity decreases from equator polewards. However, there is an aberration that salinity of the tropics is higher as compared to the equator, because at equator you receive everyday occurrence of rainfall. At the region of the tropics, rainfall is minimal and evaporation is consistent. Now, then we come to the portion of horizontal distribution of salinity. How is it that salinity varies from one region to another? So here, salinity for the normal open ocean ranges between 35 parts per thousand and 37 parts per thousand. That is the variation. On an average, as I told you, on an average across the globe, the salinity conditions are considered to be 35 parts per thousand. But it varies from one area to another. If you consider a landlocked region such as the Red Sea, where the surrounding land temperature is very high, water body's temperature also increases. And there in the water, you experience a higher rate of evaporation. And that is why you will find that there is a case of high salinity. Because obviously there will be a higher amount of evaporation in that area. So salinity can be high as 45, 41 parts per thousand, while in estuaries and the regions of the deltas around the Arctic, it has got a seasonal variation depending upon the influx of river, freezing, melting of ice. So that is why in the water bodies around the Arctic, you will observe this kind of a seasonal variation to happen. This is the variation of oceanic salinity across the world. I want you to observe certain areas. Observe this region, that is the Red Sea. High salinity levels. Why? Evaporation. Observe Mediterranean. High amount of salinity. Why? Evaporation and landlocked. But Black Sea is also almost surrounded by land from all sides, and a narrow channel connects it to the Sea of Marmara and eventually to the Mediterranean Sea. But Black Sea has got lower salinity levels as compared to the Mediterranean. Can you think about the reason why? Why is it that Black Sea has got, in comparison to the Mediterranean, a lower level of salinity? Beautiful, Rohit. Very good. Sh- Shubham, Satyam. Very good. Atharva, Volga moves into Caspian. Shalu, correct. Melting of ice. You don't observe melting of ice in the region of Black Sea. So, in the region of Black Sea, you have large freshwater supply by the rivers. You have Don, Danube, Dnieper, Dniester, all these rivers that you observe, they drain into Black Sea. So when you have a greater influx of river water, there is a greater supply of water molecules, so salinity levels reduce. So influx of river water, observe here also. lower salinity, because there is, which river drains into this region of West Africa? Are we aware? Which river drains into that region of Africa? Nile, my dear friend Vishal, drains here. That is why in this region of Mediterranean, in comparison, you'll find lower salinity as compared to the western portion. It is the Congo River. Thank you. When we think about Africa, it is not only River Nile which drains that area. You have different rivers also. So here in this river, you have the Congo River. How you can retain this is because I don't know if you remember, we studied on Friday about world climate. There in the world climate, we discussed about the equatorial rainforest of the world, where we discussed the selvas in South America, we discussed the Congo rainforest in Africa, and the Indonesian rainforest, right? So that is how Congo rainforest is around the Congo River. Okay. Now, observe the condition of very high salinity here and here. That is because this is the region of high pressure. High pressure means almost absolute lack of rainfall and continuous amount of loss of water due to evaporation. So that is why here you will find a condition of a high salinity region. Then, as compared to Arabian Sea and Bay of Bengal, you will observe the region of Bay of Bengal to be less saline. Salinity level is less. And the reason here also is similar. That is, here you have influx of very large rivers such as Ganga, Brahmaputra, Godavari, Krishna, Kaveri, Mahanadi, all of them, Iravadi, all of these large rivers, they drain into the region of Bay of Bengal. That is why Bay of Bengal has got lesser amount of salinity levels. Okay. Now here you will observe that the salinity level is particularly lower, or salinity level is particularly higher. And despite the fact that we talk about the higher latitudes where you are freezing and melting, so here you will have, first of all, the seasonal variations also due to freezing and melting, but also here you have a warm ocean current. A warm ocean current means higher temperature of ocean water. Higher temperature of ocean water means greater amount of evaporation. Greater amount of evaporation, increase in salinity. So like that, what I want you to do is take a look at this map in your own leisure time and try to find out the reasons. Take a look at the physical map of the world, keep the physical map of the world, the atlas next to it, and try to analyze the reasons why a region can have a higher or a lower salinity. Is it a seasonal variation? Is it due to influx of river, more rainfall, more evaporation, etc.? You can automatically deduce that. Okay. Now, in hot and dry regions where evaporation is high, salinity sometimes can reach even 70 parts per thousand. Salinity in general, on an average, is high in the tropics, in the northern latitude, the tropics in northern hemisphere. Okay. Tropics in the region of northern hemisphere. North Sea, around the region of Britain. North Sea is also one of the rich sources of oil. So North Sea, being in higher latitude, records higher salinity due to more saline water brought by the North Atlantic Drift, which is a warm ocean current. Right? This is a warm ocean current. Warm ocean current means greater evaporation due to higher sea surface temperature. Greater evaporation always will lead to higher salinity. Okay. Now, that is basically the case of salinity variations. We do know that in comparison to Arabian Sea and Bay of Bengal has lower salinity due to influx of river water, whereas Arabian Sea has got higher salinity because you don't have those many rivers draining into the region of Arabian Sea. You have Out of the major large rivers, you only have river Indus, and then you have few of the intermediate sized rivers such as Narmada and Tapi. That's it. You don't have large rivers draining into the region of Arabian Sea. Now, in the region of Arabian Sea and Bay of Bengal, there happens to be a difference due to the factor of influx of river water also, right? We'll come to that. So let us try to understand that the concept of ocean stratification. What is that? First of all, do we know the English meaning of the term stratification? Stratification is basically arrangement into layers. Arrangement of anything into layers, that is stratification. Establishment of different strata, that is stratification. Okay. Now, how does that stratification take place? So, when we talk about water of varying salinity, let's suppose you have a water column of 1 kg, water sample of 1 kg, having salinity of 50 parts per thousand. This is A. Another one is B, having a salinity of 20 parts per thousand. Which water, in terms of A and B, which of them will be heavier? What do you think? Which will be heavier, A or B? Good, always A, because it has got more amount of salt molecules, isn't it? So we can arrive at the conclusion that A, or water with a greater amount of salinity, will be heavier. Eventually it will have more number of molecules in the same region also. So water with higher salinity is having a higher density and it will be heavier. So water with higher salinity is heavier and denser as compared to lower salinity, right? I hope we are comfortable with this. Now, when you consider a mixture, for example, if you consider water and honey, honey is more dense. In comparison, honey is also heavier. Now, if you pour them both in the same jar, now after some point of time, honey will start settling down at the bottom, water will start coming on top, isn't it? Honey will start settling on the bottom, water will start separating itself on the top. So, based upon the weight, the heaviness, and the density, liquids have the property to arrange themselves in layers. I hope we are comfortable with the fact. So, based upon the densities here, based upon the variation in weight and density, water arranges itself into layers, right? Where we see that heavier or denser water sinks below. Okay. Now, we consider the region of Arabian Sea. Arabian Sea doesn't have much influx of river water. So let us consider the region of Arabian Sea here. Okay. Not much influx of river water, almost a consistent density you will observe, greater amount of salinity. Then, of all the issues in your life, why is it that the color of the pen is so very worrisome? Which color pen do you want me to use? Tell me, I will use that pen. Which color? Which is the color that you like? Which is your favorite color? Not red. What is the problem with red? Do you want me to use yellow in white background? Is this visible to you what I am writing? This is what is referred to as concentrating so much amount on of attention on aesthetics and forgetting the actual crux of the matter. In cricketing terms, you would have seen many of the people while they go out to bat, they take so much amount of preparation. They will get their helmet, bats, etc., everything in order. The first ball they face, they get out, right? So don't create that kind of a scenario. Please understand, this is a white background. That is why I'm using the red. I have no affinity to any particular color. Tell me the color, I will use that. Arrive at a consensus amongst you. Okay, please understand this concept. This is a very important concept that I'm telling you. This is a concept you don't find in the books. You don't find in the go through any of the current affairs portion newspaper. You don't find this concept, but this is a concept based upon which you can address mains questions which have been asked by UPSC previously. So please pay attention on the concept. Let all the aesthetics go on the side. Please understand what is your dream. Why are you sitting here early in the morning? Okay, please try to have some priority in your life. Now, here, this is the case of Arabian Sea, where you have a kind of a uniform kind of a water. Now, when we talk about the region of Bay of Bengal, now Bay of Bengal has got a high amount of influx of river water. Large amount of river water gets drained into Bay of Bengal. River water is, in comparison to the sea and ocean water, river water has got lesser amount of salinity. Ocean and sea water has got greater amount of salinity, right? River water in comparison has got lesser amount of salinity. So river water will be lighter. Ocean water will be more saline and heavier. The Bay of Bengal water will be generally more saline and heavier. So what happens is that this river water tends to arrange itself on top fresh water tends to arrange itself on top. And when you have, in that case, the more saline waters, they tend to remain on bottom. Isn't it? More saline waters will remain at bottom. Less saline waters will stay on top. Because on a daily basis, you have millions and billions of gallons of water brought into the Bay of Bengal. Eventually they will mix. Eventually, after some time, they will mix. But again, in that process, more fresh water will be brought. So always on top, you will end up finding a scenario of a stratified water, water with lower density, with lower density. Okay, so that means Because of heavy amount of influx of river water, Bay of Bengal develops a stratification which is not observed generally in the case of Arabian Sea. Now, for both of them, the source of heating is the same. That is solar insolation. The latitude is almost similar. Solar insolation is the source of heat. Now, in the case of Arabian Sea, that solar insolation, now listen to the next 2 minutes very carefully, guys. And after the 2 minutes, try to formulate your own understanding. This solar insolation, which falls on the region of the Arabian Sea. Now, because the water here is of uniform proportion, there is a kind of a uniformity in water here. Basically, you will observe that the heat distributes uniformly. Heat distributes and dissipates uniformly, isn't it? So whatever heat is being received on the surface, immediately that heat is getting dispersed, that heat is getting basically distributed very easily. So heat is not concentrating itself in one particular layer itself. Heat is basically getting distributed. But when we come to the region of Bay of Bengal, when we come to the region of Bay of Bengal, here we have water of varying density, right? Water of varying density. Now, you have seen, or if you have not seen, basically, it is the case that, for example, when you pass light through water, it tends to bend. When you pass light through a piece of or a slab of glass, that light tends to bend. Why? Because it encounters from air to glass, it encounters material of different density. That is why it tends to bend. Here, the solar rays, the solar heat will basically end up interacting with materials of various density. So these solar rays will get much more concentrated in the above portions, and some amount of that heat will be distributed into the lower portions also. Okay, but much of that heat will be concentrated in the upper portion. Some of that will be distributed downwards also. Till this point of time, any doubts in this portion? Any doubts, anyone? Rishmanjali, what was your doubt about layers? Payal, yes, Payal, that it is the same process. Any doubt, anybody at this point of time? Why not in Arabian Sea, Sakshi? Because in the region of Arabian Sea, you don't have so many large rivers draining into Arabian Sea, do you? In the region of Bay of Bengal, if you consider from east, you have Iravadi, then you have Brahmaputra, then you have Ganga, Mahanadi, Krishna, Godavari, Kaveri, all of them, they drain into Bay of Bengal. And all of these rivers, they are bringing fresh water by the day. So large amount of fresh water, and fresh water means lower density. So that is why it will stay up, isn't it? Upper layers, they don't reflect the solar rays, Sulakshana, but upper layers, they will have a much more concentrated heating. Heat will be trapped of sorts. Some heat will be dissipated to the lower portion also, but because there is difference in the density, there will be refraction of light also, and there will be significant amount of concentration of heat in a particular layer, and then the lower portion will get heated up, right? Bhavna, Tapti river drains into Arabian Sea. Yes, Tapti river drains into Arabian Sea, Narmada river drains into Arabian Sea, and Indus drains into Arabian Sea. But Narmada and Tapti, they are very small. In comparison to your Godavari or your Krishna, Narmada and Tapti are smaller. And in comparison to Ganga and Brahmaputra and Iravadi taken together, Indus stands nowhere. So that is why in the case of the Arabian Sea, you don't have that much amount of river influx. Here, you have high amount of influx of river. Now, in this case, because in the region of Bay of Bengal, you have accumulation of water, fresh water. This is your fresh water brought by the rivers. Brought by rivers. So, in the region of Bay of Bengal, on the surface, we can say that in the above layers, there will be concentrated heating, isn't it? So here, Bay of Bengal will experience concentrated heating in the upper layers due to stratification, which is missing in Arabian Sea. Because in the region of Arabian Sea, you have, I will write it in this particular slide. Please try to assimilate that. In Arabian Sea, as that heat or as the influx of fresh water is very less, homogeneity, genus distribution is observed. Of water is present, and that homogeneous presence of water means heat from the sun is distributed in water in homogeneous manner. Whereas in the region of Bay of Bengal, heat is not distributed in a homogeneous manner because you have a layer of fresh water on top. And that layer of fresh water means that some heat will be dispersed into the lower portions also. Some amount of heat will be dispersed into the lower portions also. But majority of the heat will be trapped by the water of a different density, different layer in itself. As a result of this, temperature in Bay of Bengal increases. And very frequently. Now, whenever you have a high temperature over the water body, tropical water body in particular, which kind of atmospheric phenomena is resulted? What atmospheric phenomena is a resultant of a high oceanic temperature? Beautiful. You have a tropical cyclone. So leads to frequent tropical cyclone. This is one of the other reasons why you will experience more frequent tropical cyclones occurring in the region of Bay of Bengal as compared to the Arabian Sea, and that is because of the stratification of water. And it is not only the case of Bay of Bengal. If you observe the world around, even in the region of South China Sea, large influx of river water. Even in the region of Gulf of Mexico, you have the river Mississippi draining here, and other rivers also. Influx of river water here also. So that is why in these areas you will generally experience greater formation of tropical cyclones. UPSC has already asked this question in the mains examination. Why is it that the region of Bay of Bengal, South China Sea, and Gulf of Mexico experience high frequency of tropical cyclones? Now, majority of the candidates, in fact, 99.99% of the candidates, when they write the answer for that, they will tell you, or those of them who are actually appearing for the mains examination means serious enough, they basically write the answer that, look, this is the region of the trade winds. And these trade winds, see, I cannot use the color without thinking now. Which color do you want me to use? I'll use red here. So here they will generally write that you have these trade winds. These trade winds, they cause downwelling in this region, meaning a higher sea surface temperature. These trade winds will cause downwelling in this region also, higher sea surface temperature. Here also, higher sea surface temperature, and they will write the answer around them. That due to higher sea surface temperature, low pressure is created, and they will talk about the formation of cyclones. If you want to create a difference in your answer, if you want your answer to look different from what the masses are writing, that is only when you will be able to secure a marks which is higher than the competition. So that can happen only if you provide these innovative pointers. That is why I am telling you, please concentrate on these innovative pointers. The crux of clearing this examination is not that a question of geography has been asked, I will answer only about what is a geographical parameter. A question of geomorphology, only geomorphology. No. Any Tom, Dick, and Harry can do that. 10,000 people appearing for the mains examination, everybody has studied more number of books than you. Everybody has studied more than you. Everybody will be able to do that. What is the difference you are bringing to the table as a candidate? Your ability to interrelate climatology with oceanography, geomorphology with oceanography, geomorphology with climatology, all of them and their interrelation with Indian geography. That difference that you are able to bring to the table, that is the only difference that actually counts in the exam. Okay, so if you are thinking that in the 15 marker question, I will go rise up early in the morning, I will basically comb my hair so beautifully, I will do all the worship and the veneration, and I will get good marks, it doesn't work like that. Okay, so that is why try to bring these points into your answer also. I hope this is understandable. It is a kind of an internal reflection, but not a complete total internal reflection, Chandrajyoti. What I wanted to tell you is, what I wanted to convey here is, in the region of Bay of Bengal, you have stratification of water. Water of different densities, when they arrange themselves in the layers, that is stratification. When you have the low density water on top, so the solar rays which will come through, some amount of that will be trapped in that layer. Some amount of the remaining will be passed on to the lower portion. As the heat is trapped into that layer, means a frequent rise of temperature. Okay, right? Now, after that, we come to the vertical distribution of salinity. I hope this is understood. Yes, Sulakshana, in the case of Bay of Bengal, right? Uh, the western slope, Shubhankar. The western slope of Western Ghats experiences more rainfall. Then where does this water go? Is it not getting mixed in? Very good question, Shubhankar. For that matter, if you are thinking in this particular manner, that is good. But understand, the amount of rainfall received is how much? Around 400 centimeter, in certain areas 250 centimeter. That will under no condition will that be able to influence the overall consistency of the region of Arabian Sea as compared to a large Ganga or Irrawaddy or a Brahmaputra or a Barak, them draining into the region of Bay of Bengal. So that is why influx of river water, because please understand, even the northeastern region, will receive very high amount of rainfall. The Tanasarim, Arakan Yoma, Pegu Yoma coastline of Myanmar, very high amount of rainfall, almost equivalent to the Western Ghats. So all that is also there in the Bay of Bengal. Plus, to add on to that, you have large river systems. Okay. Now, why things floated on high salinity of water is it is because of density, the force of buoyancy rather. Now, how does salinity vary in terms of depth? Now, before going through it, understand a particular concept. Everything that we have studied till now, temperature variation, or that is rather evaporation, precipitation, that is rainfall, melting, freezing, all of these, influx of river water, everything that we have studied, all these factors are relevant only in the upper levels of the water in the ocean. Ocean is around 5 kilometers deep, on an average 5 to 6 kilometers deep. Now, evaporation, precipitation, everything that is happening, it is a surface phenomena. If it is raining in the region of Indian Ocean, do you think the base of the Indian Ocean will have any change at all due to temperature, etc.? Any change at all? Absolutely not. Right? It will be calm. The reason why life was able to sustain on the planet despite all the harsh conditions on the land, despite all the untoward incidents on the land, numerous volcanic eruptions, endless amount of storms for millions of years going together, still life was able to sustain underwater. Why? Because after a particular depth, all these impacts, they are not at all felt. It is only up till a depth of around 400 500 meters from the surface where you feel the impact that yes, an ocean current is coming from here, or yes, there is greater rainfall in that region, there is greater evaporation in that region. So what I'm getting at is the fact that the ocean bottom, be it in the form of temperature or be it in any other condition, they represent a kind of a static or a kind of a consistent scenario, consistent conditions. So, in the region of the ocean bottom, the conditions are almost consistent, but there is a surface variation. Higher latitudes, different amount of evaporation. Lower latitudes, high amount of evaporation. Tropics, very high amount of evaporation. So all these surface phenomena, they vary from one region to another. But in all these areas at the bottom, absolute close to the ocean floor, the conditions are consistent. What is known as the benthic zone of the ocean, there the conditions are consistent. So if you have to chart out a graph representing the variation in salinity from the surface to the bottom, you'll find that whatever be the condition of the surface, high salinity, low salinity, intermediate salinity, whatever be the conditions on the surface, as you go to the bottom or the depth, salinity levels will start becoming consistent around 35 parts per thousand. Around 35 parts per thousand. Salinity levels will be consistent. So, what that actually indicates or means is basically that from surface to lower on, there will again be a zone of transition to reach that 35 parts per thousand. That zone of transition of temperature we studied in the ocean is known as thermocline. That zone of transition of salinity in ocean is what is referred to as halocline. Here, halo is derived from the term haline, the salt conditions. So that is where halocline. So basically, salinity changes with depth, but not same on all locations. Halocline, it is similar to thermocline, but it measures the change in the salinity zone. Surface salinity we have studied. Salinity at depth is very much consistent. So if you have to represent a curve for halocline, here, for example, here you will observe that observe the region of the tropics where the salinity level is the highest due to highest amount of evaporation. Salinity level is highest. It is the lowest in the region of the poles where we have seen that salinity reduces from equator polewards. Other than the tropics, tropics are an aberration. So wherever you talk about it, the salinity levels, they start to decrease and they reach a consistent value. They reach a consistent value. They reach a consistent value. So that zone of transition where from the surface variation the salinity reaches a consistent value at the bottom, that is what is known as halocline. So this zone of transition is what is known as halocline. That is what is known as halocline. Okay, can we relate it? Can we relate cyclones in Bay of Bengal to La Nina in previous? Absolutely, yes. Absolutely, you have to. Right. So Bay of Bengal, Walker circulation, you have to relate it to La Nina conditions, El Nino Arabian Sea, IOD. So you have to relate it to that. Can we say salinity, that with depth salinity increases? Not always the case. Observe that in the region of the tropics, salinity is maximum at the surface, at the base it is less. Okay, so that is not always the case. So higher salinity is much more denser and stays below the water having lower salinity. Higher the density, deeper is where the water goes. This property leads to ocean stratification, arrangement of ocean water into layers based upon their density. That is what we refer to as ocean stratification. Okay. Now, highest salinity in water bodies, you will observe Lake Van in Turkey having a salinity level of around 330 parts per thousand. That means in 1 kg of water, you will have 330 grams of salt, right? Then Dead Sea, 238 parts per thousand. Great Salt Lake, 220 parts per thousand. So these are the, generally, you will find a trend in general, enclosed, smaller water bodies with higher temperature and higher. Ashish, name me few of the other lakes in that area about salinity, higher temperature and higher evaporation. Okay, region of high pressure, region of subtropical high pressure, high pressure leading to lack of precipitation. That is a common factor. Yes, Shalu, that is correct. So, Ashish, your question was why Pangong Tso is saline in nature. Pangong Tso has got a high salinity, as you would observe in many of the water bodies in that area. Many of the lakes in that region will represent salinity because there you don't have much amount of precipitation. Rainfall is almost absent because in the region of Leh and Ladakh, these are basically the areas of cold deserts, cold dry deserts. So almost no precipitation, and you have evaporation because the solar insolation is high throughout. You will have evaporation. Plus, to add on to the fact that the nearby rocky areas, they will always keep on giving the substrate and the materials into these large lakes. That is why it becomes saline. Okay. Why I asked you this particular question about the other lakes in this region, because I understand that majority of us, when we talk about the portions of these Pangong Tso, etc., we are so very much influenced by the information we get from. That is the reason why I get questions that what happens in Dead Sea, what happens at Mount Kailash, What happens at Bermuda Triangle? What happens at Pangong So? So that is what I refer to as the social media phenomena. But anyways, at high latitude, why salinity do not increase due to freezing of water? It does increase. It does increase. If there is a freezing of water, salinity will increase, but it will never be as high as the tropics. In the tropics, it is very, very high. Ocean stratification basically refers to the fact, okay, arrangement of waters, of ocean water in layers based upon variation in density and weight. Example like water and honey. I hope that is understood. Okay. So now we come to the portion of the density of water. Density of water. Now, density of anything represents how closely materials are packed together. That is what is represented by density. So, when we talk about water's density, so differences in water density will impact the vertical mobility, vertical motion of the water. Water with high salinity is denser than water with low salinity, right? Because you have more salt content. Cold water is denser than warm water. Always. Cold water, just like cold air is more denser than warm air, cold water will have more number of particles as compared to warm water in the same region. Hence, cold water is denser. Now, when we talk about various different areas, for example, higher latitude. So, density of water in higher latitude. What do you think? In higher latitude, due to freezing, salinity is high, then cold water. So, as a consequence of this, what will be the density of water in higher latitude? Density, will it be high or low? Density will be very high. Now, similarly, at equator, let's suppose at equator, at the region of equator, rainfall is high, isn't it? So, salinity is comparatively lower. Is lower, right? Temperature is warm. So, what about the density in this region? Density, will it be high or will it be low? What do you think? What about the density? Very good. Low density. So that means we are comfortable with this concept. Now tell me, at the tropics, temperature is very high, warm water, salinity is very high. So if you consider the factor of temperature, warm water has got less density. So if you consider the factor of temperature, it should be less dense. If you consider the factor of salinity, it should be very dense. So what do you think is the density at tropics? Is it high or is it low? Medium, moderate, okay. Middle path. Buddhism are we following? Are we? Okay. Why density is high? Those of you saying density is high, why do you think density is high? Only because of salinity conditions, is it? So if only salinity conditions were to be determined, then we could ignore the conditions of temperature altogether. And those of you are saying low, why do you think it is saying low? Okay. So understand one thing. Wherever, at any point of time, both salinity and temperature, listen to this carefully, at any point of time, at any region, whenever salinity and temperature both are the determining factors and they can determine in either way, density will always be dependent on temperature, right? Whenever you have the condition where both salinity and temperature are the determining conditions at the same time and they can be contradicting each other, temperature will always be the determining factor, period. I will repeat again. Temperature and salinity, if both are the determining conditions, temperature is the determining factor for density. Why? Why is that the case? That is because let us consider two columns or two parcels of water. Let us consider. Now here you have salt also, water molecule also, large amount of salt also, large amount of water molecules also. Here you have water molecules. Now, if I heat both of them up, if I heat them up, what will happen? It will tend to expand. The particles will tend to move away from each other due to heating, regardless of whether there is salt, whether there is water molecule, whichever it is there. If I heat them up, it will expand. Always any state of matter due to heating tends to expand. So what will happen as a consequence? The density will lower down, isn't it? So that is why temperature becomes a determining factor, and hence at tropics here, Shalu, that is what I have been repeating so many times. At tropics, you will have low density. What you are saying, Shalu, is the same that I have written here. You are saying that at tropics, evaporation is high, salinity is high, so how there is contradiction. Again, I will repeat. Open up your minds for a brief moment. Open up. Think about it. Whatever I understand or whatever you have understood, for a brief moment, erase it all. Listen to this carefully. Whenever conditions of temperature and salinity both are at stake to determine the density, density will always be determined by temperature only. Why? Because regardless of the fact that whether a water has got high salinity, low salinity, minimal salinity, very excessively high salinity levels, whatever is the condition, if the temperature is high, if that water is getting heated, what will happen? Water will tend to expand, there will be an increase in volume, particles will move away from each other. As the particles will move away from each other, so will the salt molecules also move away from each other. So what will be the density of water? Density of water will reduce, isn't it? That is why whenever you have salinity, temperature, other conditions, temperature is the final deciding factor and the more important factor for salinity. Is that understood now? Understood? No? Okay, good. Now, here we move on to a concept whereby this variation in density, we experience circulation in water. Now I'll use a different color so that you have less issues with that. So here Basically, there is a circulation induced between the lower latitudes of the planet to the higher latitudes for exchange of heat, nutrient exchange, etc. And that is because of the variation in density. What is also referred to as thermohaline haline circulation. Now, understand a basic concept first of all. Before this, understand a basic concept here. Payal, I don't think even a rainbow will be able to satisfy the demands as students. The demands which are there is always ever persistently higher. Now, let us consider this is the water column at different latitudes. Let us consider this to be the region of equator, or in general, let us consider low latitudes. We do know that in lower latitudes, the density is lower, or in simple terms, in lower latitudes, the heating is higher. And let us consider this region to be higher latitudes. Now, here, and again, listen to this concept carefully for the next 5 minutes. It will help you understand many of the eventual concepts of ocean circulation which happens across the globe, relevant for the portion of your current affairs. When we'll come to the, for example, global conveyor belt system or Atlantic meridional overturning circulation, this will be of immense help. Now, in the lower latitudes, the amount of solar insolation is very high, right? In general, around equator, tropics, the amount of solar insolation is very, very high. Now, as the solar insolation is high, means the heating is high. Now, water, just like any state of matter, when you heat it up, water will also expand. Eventually, if the heat is very high, it will get converted into vapor, etc. But water will tend to expand upon heating, isn't it? Now, in the region of the lower latitudes, generally you will observe that due to excessive amount of heating, the water column tends to expand, the density lowers. From the lower portion, the water will start rising up. There will be an expansion. Due to that expansion, what happens? Water tends to develop a kind of a height gradient in the area. Due to that expansion of water at the lower latitudes, water tends to expand and gain a height advantage around 8 to 10 centimeter as compared to the water in the higher latitudes. Because in higher latitudes, due to very cold conditions, water will tend to compress. Water will tend to have an accumulation of material. Density will be very high. So in the lower latitude, due to heating, there shall be ever so slight amount of expansion taking place. Right? So there is a height advantage that water has in the lower latitudes. Water has got a kind of a height advantage. Around 8, 10 centimeter, 12 centimeter if the heating is very large. But that's it. Now, water will always flow from a greater height to a lower height, always, regardless of the scenario. I am sure, regardless of how innovative you are and how ingenious you are, you would never have come across a scenario where water is moving from a lower height to a greater height, always from a higher height to a lower height. So, here also, as the water has gained height, it will initiate a motion where towards the region where the water has lower height. As the water is in motion here, it is moving towards higher latitude. So it will start getting cooler along the way. Maybe the temperature was 24, 25 degrees Celsius here. The temperature would have reduced to 10, 12 degrees Celsius by the time it has come here. Furthermore, that it goes, the temperature will reduce to maybe even lower than that. Furthermore, that it goes, it will reduce even lower than that. As it reaches the higher latitude closer to the poles, many portion of the surface water, they start to freeze, right? So the water becomes very cold. There is freezing also. Okay. So what happens as a result of that? So here, now I'll use a different color. So due to very cold condition, density increases, isn't it? Now, after that, if thermocline and thermohaline were the same, my dear friend, why would I have written thermohaline? I would have written thermocline circulations. Obviously, they are different. That is why I've written it differently. If they would have been one and the same. Now, also, due to freezing, into ice. What happens to salinity when there is freezing action? Salinity tends to increase. Salinity tends to increase. And when the salinity increases, what happens to the density? So in lower latitudes, density was low due to heating. In the higher latitudes, the density will be very high due to various conditions. So as the density goes to be very high, this water which was brought over, its density has increased. So that water will start to sink down because density, higher density means heavier. So it will start to sink down. Now it will go up till the intermediate level. Meanwhile, in the lower regions, as the surface has flown off, more water from the lower regions will rise up. They will also get heated up. They will also start flowing. Again, more water from the lower regions will rise up. They will rise up. They will get heated up. They will expand. They will start flowing. So there is a kind of a vacancy which is needed to be filled. And that is where you come through or you observe a circulation of water, where on the surface, the water moves from the lower latitude to the higher latitude, but on the subsurface, water moves back to the lower latitude. But this circulation that you have seen, this circulation is purely because of salinity conditions and because of temperature variation, right? Salinity has increased, temperature has decreased, salinity has decreased, temperature has increased. It is only because of this variation that the density is varying. And it is because of the variation in density that you have the water sinking down and coming up, isn't it? So this circulation is what is known as thermo, means temperature, haline, salinity. So a kind of a circulation which is dependent on temperature and salinity conditions, where the density variation happens because of temperature and salinity conditions, that is what we regard as the thermohaline circulation. Okay, so when you talk about thermohaline circulation, you will generally observe warm water from the lower latitudes, they come towards the region of the higher latitudes, they get cooled down in the region of the higher latitude, they get very cold, they start to sink, and then they recirculate back as the subsurface water. So that is basically the case of thermohaline circulation, or circulation initiated due to temperature and salinity conditions. Okay. Yes, Yasmin, it means that lower portion of ocean water is flowing from higher latitude to the lower latitude. I'll show you the entire global circulation also. So if you take a look at it, the entire global circulation, if I have to show you, for example, let's suppose we consider this. So observe, as it goes towards a higher latitude, it tends to sink, move as subsurface water. As subsurface water, it tends to move in various areas, isn't it? Again, when it will get heated up, it will rise, flow as surface water. So this is induced because of circulation of water, and this is something that you experience in oceans across the world. Now we come across to the movement which is observed in the oceans, and the movement in the form of tides and waves. So we start first of all with the movement or the occurrence of waves. Now, what are waves? So when we talk about waves, creating waves, waves are basically the undulation, smooth movement of water in upward and downward direction of surface water, characterized by well-developed crest and trough. What is a crest and a trough? So basically, when we observe an uphill type of or an upfold, that is what is a crest. This is a trough. Now the problem is, again, sometimes due to lack of information, sometimes because we are over knowledgeable and over informed thanks to the social media sites and networks, etc. Majority of the individuals, 99% of the individuals, you will find they will confuse between waves and tides. They will tell you it is a time of the high tide is coming, so the high tide is very dangerous. So, and you see they are referring to waves. Sometimes when they refer to the waves on the ocean, for example, they observe this, they refer to it as tides. Right. So people use waves and tides interchangeably depending upon what their mood is, what is there on the tongue. But there's a significant variation between waves and tides. Waves and tides are very, very different phenomena. When we talk about waves, that is where, if you have the oceanic water like this, due to the movement of the winds, you observe the oceanic water to have a crest and a trough. That is a wave. When we observe or when we say a tide, so in the case of a tide here, if let's suppose this is the level of water, now during some time in the day, that water level rises up. And during some time again in the 24-hour cycle, that water level falls down. So in the case of a tide, the water level rises up in the ocean and goes down in the ocean. Every day this happens. But in the case of wave, nothing of that sort happens. So there's a big difference between wave and tide. So the next time when you go to the coastline or when you interact with your elders, please understand that both of them are not the same. Now, here, tides occur on a daily basis. It is not only on the full moon and new moon, tides occur on a daily basis. Now, why is it that the waves occur? So let's suppose you have wave is reason for tide. Absolutely not. Absolutely not. When we talk about the ocean water, this is what the from our childhood days we have been fed with such amount of confusion. So here, when we talk about a wind movement in this area, now the wind ideally will have a kind of a frictional drag against the water. That wind, as it comes, it will rub against the water surface. It will try to carry water due to the frictional drag. But how strong will that be? Will it be able to carry water all the large distance? No. So here, as this wind, let's suppose you have a wind movement, as it tries to carry that water here, that water is carried by it. But then again, beyond a point, it cannot carry. It is dropped. Then the wind carries water from this region, then water from this region. Now the water portion which has dropped will try to come back to its original position. Right. So that is how you will observe in this case. Observe this particular image where you will observe that generally this is the wind motion. You will observe that it tries to carry the water, but then again it drops it back. Again, in that being point of time, some other portion of water is that which is carried, then some other portion is carried. So, like that, you have a consistent wave of crest and trough which is created. So, whenever you have the crest and trough, a significant crest and trough, let's suppose this is your crest, this is your trough. Whenever these consistently get created, so a region which has a crest, after some time this will be the region of a trough and this will be the region of a crest, right? So that is something which you observe in commonality. That is something which you will observe as a consistent feature. In general, if you have to talk about the particle motion, how is it that the particles of water are moving? So water particles here, they are getting lifted up by the wind. They are carried by the wind for some distance, and then they fall back into the same area, right? Again, carried by the wind over. So that is why you will find that the water molecules here, the water particles here, observe the motion of the water particles. It is being brought up, it then falls back to its original position. So the water molecules move in a circular, repetitive, or oscillatory kind of a movement. So water particles move in a circular, oscillatory motion. Now, if you have ever stood on a coastal area, on the coastline or the shoreline, you would have experienced that the wave brings water towards you and then the water retreats back. This is a consistent phenomena that you would have observed, right? If you have the coastal area, if you have this as the coastal region, and here you have the water, you would have observed that there are formation of large waves which strike and the water comes in this direction and then flows back also. So the movement of water towards the coast by these waves at the coastline, when the water hits and it moves towards the coast, that is what is referred to as swash. So movement towards the coast is swash. And the movement again towards the sea, away from the coast, movement away from the coast towards the sea, that is what is known as backwash. Movement away from the sea or away from coast towards the sea is known as backwash. Okay, right? So that is the case of swash, and backwash. Array, my dear friend Chandrajyoti, I have a serious confusion. At tropics, the temperature is higher due to highest insolation. So, what density is highest at tropic or at equator? Generally, you will observe that it is not always fixed in terms of density parameters. It is not always fixed that at equator only you will have highest density or at tropics only you will have highest density, because there is a variation in terms of rainfall and precipitation. Because there is a variation in rainfall and precipitation, that is why sometimes you will find that the high density is or lowest of the density is found at the tropics, sometimes across the region of equator. Generally, you will find that in the region between the equator and the tropics, that is where the movement of the water begins. But why is that a serious confusion, my dear friend? Is that understood now? It is not a big deal that whether this is basically the case of that if the tropics will have, most of the times you will find the tropics due to very high temperature will have low density, but the salinity factor or offsets it. But in the region of equator, you will have lower salinity and warmer temperature at the same time. Okay, right. Ice is less dense than water. Fair enough. So waves are occur due to wind movement. Tides are different, Sandeep. We'll talk about tides. Yes, Rohit, more or less the same. In the beach, the water that you experience coming in and going back, that is a wave. But if you live in a coastal area, or if you have lived some time in the coastal area, you would experience that water level rises up during midnight. It rises up, then during 2:30 or 1:30 or 2:30 in the afternoon, again the water level enters further inland, and that is basically the case of the tides. Okay. Now we come to the portion of tides. In the case of the tides, what you observe is a vertical variation. The height keeps on increasing and decreasing. Okay. The height of the ocean water, that varies. It keeps on increasing and decreasing. And across the planet, this is something which is observed. Now, this happens mostly twice a day. Twice a day, you will experience the water level to rise up. Mostly twice a day, you will experience the water level to come down. So, that vertical motion or the vertical variation in the height of the sea surface water, that is referred to as a tidal movement. Now, tides happen because of forces. What are the forces? You have the case of gravitational pull of sun and moon, and due to centrifugal force. These are the two forces which are responsible for the generation of tides. Okay. Now, when we talk about the gravitational pull of the sun and the moon, sun is very, very large. So, gravitational pull is very strong. It will have its own gravitational influence. But moon is very close to the earth. So, what it lacks in mass is made up with the short distance. So, moon will also have that gravitation. And the impact of moon for that matter is much greater, much higher. So that is where every day in areas across the planet, now understand, when we talk about the gravitational pull of the sun and the moon, they are nowhere that strong that they will be able to pull the planet away or they will be able to pull the land masses away. No, but they are definitely strong enough to influence a variation in terms of the water level, right? So, for example, if we consider this, so the major causes gravitational pull to the great extent the moon's, and to small extent the sun's gravitational pull also. So, observe here. This is the moon. Let's suppose this is the ocean around the planet. Now, the gravitational pull of the moon will attract it significantly, right? So, where does that additional water come from? So, there will be a kind of a bulge in water column here due to that attraction. But where will that additional water come from? Is it the case that suddenly on the planet more water will come into existence? No. This will be pulled in from these areas. These will be pulled in from these particular regions. Isn't it? Now, as you have the development of this particular kind of a bulge, what you observe, there will be, in order to gain equilibrium, there will be, because the planet is rotating consistently on its axis, there will be a development of a counter bulge on the other side also. So these regions will experience high tide. These regions will experience high tide. These regions, the water level has gone lower, so they will experience low tide. Now let's suppose the moon has come here. If the moon has come here, now in this area you will observe a kind of a bulge. This region you will experience a kind of a tidal bulge, so you will have a high tide here. And then in this area you will have water which is drawn out from this area. Right. So the regions which had experienced low tide will now experience high tide, and vice versa will be the case. Again, let's suppose the planet rotates, the position of the moon is here. Again, let's suppose the planet rotates, the position of the moon is here. So that is how here you have two conditions of high tide and two conditions of low tide within a 24-hour cycle, which is experienced in different areas. Okay, that is the case of the gravitational influence and formation of tide. You have the centrifugal force also. It is a combination of both of these factors which gives rise to the tidal bulge. The centrifugal force and the classification of the tides we'll do tomorrow, when we'll carry on with the portion of ocean currents, and then eventually we'll enter into Indian geography tomorrow also, tomorrow itself. Okay. Now let's take up few of the questions and then we end the class. Tide is formed in the middle of the ocean. Not always. In the coastline also tides are formed, Shabir. Waves are also formed, yes. Because we generate power with tidal energy, not with the wave energy, yes. Because waves are not always very consistent. Tidal energy, the variation in the height, that is always consistent. So because of that variation in height, you have the influence. How tall a wave can be, it depends and varies from region to region. In certain areas, for example, go to the coastline of Puri, you will have the waves which are very, very small, a couple of meters at max. Go to areas, for example, even for that matter, in western coastline. Go to the region around the southern part of Maharashtra, the coastline, very high waves. You have regions in certain parts of the planet, for example, in Australia, you have certain areas where the waves can be around 10 meters high. Okay. And if there is high salinity, then a person won't sink in water. Mohanraj, when the salinity level is very high, that means the density of water is very high. And density is an important factor in what sinks and what floats. That is why generally you have that tendency. In lower latitude, evaporation takes place due to high temperature. Then how salinity is low? Who told you salinity is low? Salinity is lower in equator as compared to the tropics. Salinity level is the highest in the tropics. Tropics are also considered a part of the low latitude, Sagarika. So always understand, salinity is dependent. Salinity is very high in the tropics. It is slightly lower in equator because there is continuous and a daily occurrence of rainfall. Okay. Counter tidal bulge is formed in the counter tidal bulge is formed in opposite side of the earth. So when one tide is forming in Indian Ocean, so see, the nearby accumulating waters will give more water into the region of the Indian Ocean, but the exact opposite, maybe in the Pacific, maybe in the Atlantic, there will be a counter bulge which will develop. And how freezing leads to increase in salinity, because whenever you have the event of freezing, it will utilize the surface water. So again, there will be net removal of water, right? Some amount of salt will also be consumed, but overall there will be net removal of water. Hence, there will be increase in salinity. Anjali, for that, you will have to go through the portion of geography from very basics. I hope you have the pre-recorded tablet lectures other than the live class lectures. So go through them, the basics of geomorphology. We have used certain animations, etc. So get used to that, get that basic concept right from the initial portion very diligently. Don't get attracted by the general phenomena of popularity that I say. For example, I have just started climatology, but my first question that comes to my mind is, what is a cyclone? First understand what is a condition of a cyclone, what is a condition of a high pressure, low pressure. So approach it with that basic, it will be understood. And in tsunami, biggest tides will be formed. Remember the portion of geomorphology, module 3 when we were module 4 when we were discussing about earthquakes and the volcanoes. Remember, we talked about that whenever there is an underwater earthquake, it leads to the generation of disturbance of the water body. So that is where we have studied it already. Yesterday, you had a massive earthquake. Day before yesterday, you had a massive earthquake in the region of Philippines. A tsunami warning was issued across the region of the Pacific. Okay. Yes, Atharv, that is correct. So that is where I'll conclude the session here today. We meet again tomorrow morning and then we continue further. Do take care of yourself. Goodbye. Thank you.